This week you read a literature review summarizing the research on math CBM, and this presentation will highlight some of the conclusions from that review. As they describe in their review, there are two broad approaches for developing curriculum-based measurement tasks: curriculum sampling and robust indicators. So let's talk about each of them. For curriculum sampling, we're going to make our measures by using items from the actual math curriculum. So we look right in the math textbook and what's covered for this year, and we take a sampling of those problems in our assessments. And that's applied to both our computation problem and our applications problem. So if this year the students are learning their 1-digit and 2-digit addition problems, then those are the type of computation probes we'd be focused on. And our concepts applications, word problems, graphing types of problems, and again, they're going to be linked to the curriculum. So that is an advantage, that direct link to the curriculum, because if a student performs poorly on your assessments, you'll be able to look right back to the curriculum at what skills need to be targeted, what lessons need to be taught again, where the students need extra support. The disadvantages are you're going to use a different measure for each year. So now the measure that you're using now, it's linked to that curriculum, those target skills for this year. So I'll have to change. I won't be able to assess the student's growth over several years. And my results don't generalize. So what my results are is how the student's performing in this curriculum with these targeted skills, not how they're performing overall in math. So this is, again, are going to be more of our specific sub-skill mastery. Linked to the curriculum, assessments have to change. Now we talk about our robust indicators. Here we're more talking about a general outcome measurement, and here is our CBM, which is our most research-based GOM model. And it's a measure that represents broadly defined proficiency in math, and it doesn't have to be linked to the specific curriculum. So like oral reading fluency. If we know a student's performing well with oral reading fluency, we know they're on track with reading overall. And we use robust indicators, we know that students are on track with their math progress overall. So an advantage here, one measure can be used across years. So you can use this assessment starting in first grade, same type of assessment on and on to make sure they're making progress, and measure growth. Disadvantage is going to be less useful for intervention planning. So like we've discussed with GOM and CBM measures, it is that vital indicator that the student's on track in this area, math. But it doesn't tell us exactly where we need to target for intervention. It will tell us they're on track or there's been a problem and we need to look deeper. And that's where we'll get into those specific skills, the specific sub-skill mastery measures, things that are going on in the curriculum. So research has examined the technical adequacy of both robust indicators and curriculum sampling approaches. And generally we find strong reliability with coefficients above 0.80, which is what we want. Lower reliability for more complex problems, and that can be understood. And then validity coefficients ranging from 0.5 to 0.7, which is modest, but that's similar to most available math achievement tests. And again, what this is saying is that if we're using math CBM, so looking at digits correct per minute, and through brief timed probes, that we will have a good idea of how a student's performing in math and whether they're on track or need intervention support. And then in addition, we can use these data to tell us if a student is responding to those interventions or if additional changes are needed. The elementary math CBM measures they looked at included the monitoring basic skills progress, which is a curriculum sampling measure based off the Tennessee curriculum for grades 1 through 6 for computation probes, and then grades 2 through 6 for those concepts applications probes. So again, if you were going to use this kind of measure, you would need to know if there was an alignment between the curriculum they sampled from and the curriculum the students you're assessing are in. Another CBM measure they looked at were problem-solving measures using word problems from instructional curriculum. And then our basic fact probes. So that's your basic sheet of addition, subtraction, multiplication, or division, or mixed skill probes like that. And again, for these, we're looking at digits correct per minute for all of these math CBM measures. So the review also looked into the technical adequacy of early math CBM measures, and these have only been done on robust indicators. So again, these measures look at overall if a student is on track for math performance, and the measures include quantity discrimination, which is just the students given two numbers and they say which one is bigger. Identifying the missing number, whereas students given a sequence of 3 to 4 numbers and they're to fill in the blank with the missing number. And number identification, where they're just giving a probe with a bunch of numbers on it and asked to name the numbers. And there's strong reliability, and the validity coefficients were a little lower than we saw for the elementary measures, but they do get higher when we get into first grade. So some recommendations from the review include that when you're looking at these approaches, they each have their own advantages and limitations, and that needs to be considered in deciding which approach to use. If we are considering using the MBSP computation, again, we have to evaluate that match with the curriculum. So anytime you use a curriculum sampling approach, it needs to be linked to the actual curriculum. Whereas when we're using robust indicators, that's curriculum independent. And then for math CBM, we don't see performance improve as rapidly as we see with reading CBM. So the measures might not be as sensitive as reading CBM. So we need to be a little more patient with our data collection. We wouldn't want to stop implementing an effective intervention because our measure wasn't sensitive enough.